This is the real Tom Rose, and this problem is pretty tricky. It says from the triangle below, determine sine of 2 alpha. At first I thought like maybe I need to use the half angle formula on this, which you don't need to do, which would be 2 sine alpha cosine alpha. But I didn't know how to get either of those. So I worked a little bit more, and eventually what I discovered is that the clue that tipped me off was this 2 root 3. I was like, that's strange that they would pick such an unusual number for that. And I said, do I know any special triangles that have numbers like that in them? And I realized that I knew one that was close. It wasn't exactly, but I knew a triangle that had a root 3. Not 2 root 3. But I said, what if we divide it in half? That's a right triangle, and each side is root 3. Right, if the sum is 2 root 3? Well, what is a right triangle that has lengths of 2 and root 3? It means the other length is 1. This is a 30, 60, 90 triangle. And the 30 degree alpha is the 30. This is the 60. It's the triangle's not drawn to hardly at all to scale. The triangle should, when drawn accurately, should be more like this. Right? Here's your root 3, here's your 1, and here's your 2. That's closer to scale drawing of this triangle based on the numbers that they've given you. So that's part of what threw me off. So this is 30 and this is 60. So they said, what is the sine of 2 alpha? Alpha is 30. We just figured that out because we figured out the 30, 60, 90 triangle. Sine of 2 alpha is like saying sine of 60. Well, sine of 60 is, sine is opposite over adjacent, right? Sorry, opposite over hypotenuse. Sine of 60 is equal to root 3, which is opposite, over 2, which is that guy. That only works for right triangles, by the way, but that's what we're using.